All right, I think it's time to think about putting this in a box and having its own power supply. It's about that time. So I thought I would use, let me bring it over. I would use this. So I showed this in one of my videos. It's a HP 435B power meter. And what's really cool is it's got a whole bunch of steps on the front. Right? It's got a switch with a whole bunch of steps. 1, 2, 3, 4, 5, 6, 7, 8, 10 steps. And then there's another one here that's got a whole bunch of steps. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, a whole bunch of them. So power switch. It's got a power supply. On the back, it's got 2 B and C's, so X, Y outputs. It's the perfect box, right? Perfect box. Well, not so perfect. So I actually wired it into this thing and turned it on, and it didn't work. I thought, what? And turns out that the power supply in this thing isn't enough. You would think this would not take much power, right? You would think. But let me show you here's the schematic for the HP. Let me move the camera. All right, so here's AC coming in. There's a filter. There's a transformer. Goes into a bridge rectifier. Goes into the circuit and generates plus minus 12 volts. Perfect. But when I hooked mine up, it kind of shut down, and so there must be a current limit. And I found the current limit right down here. So in this leg, there's no resistor, but in the bottom leg, there is a resistor. And so it monitors the current here. Now this is a kind of a funny split rail power supply, so the return path is always going to be through the bottom here. And there is I know this is going to be small. Anyway, there is a transistor here, and across the base emitter voltage is a resistor. So this is very similar to the circuit we saw when I was increasing the current of a 3-terminal regulator. There was a thing like this. If the voltage gets too large across the resistor, then this transistor turns on. Well, in this particular case, when this transistor turns on, it shuts things down. So if the VBE drop across the transistor is 0.6, 0.7 volts, it appears across this 6.8 ohm resistor. Now that sounds pretty low, but if you take let's say 0.7 volts and 6.8 ohms, that's only 100 milliamps. And it actually fires, it's actually about 0.62 volts for that particular transistor and 6.8 ohms. It's actually 91 milliamps. Reading the service manual, they say 90 milliamps is when this thing was designed to turn off actually. So 90 milliamps is not enough to do my little curve tracer. So I could change this resistor and have it operate harder, but then I'm worried about, is the transformer large enough? It does have a small transformer, so maybe 90 milliamps is about all we can get out of this thing. So I think the thing to do next would be, let's go ahead and test this thing without blowing it up. So I think what I'll do is I will short this resistor out and then put a dummy load on these supplies and see how much current this thing will actually supply and whether it's enough or not. Plan B Plan B is to actually try to put in a power supply. Now this is a nice +5 ± 12 volt power supply. It's about the smallest one I've got. You know, it's not that big as far as power supplies is concerned, right? My hand covers it up. It's just, does it fit in the box? Let's see. Yes. So it'll eat up, you know, a portion of the box. There still may be enough room for the curve tracer in there, so we'll have to deal with that. But I think we'll leave this on the bench. I think what we'll do is see if I can't measure the actual current capabilities of this power supply with its transformer. Open it up. All right, here's the underside of the instrument, and you can see the transformer. It isn't very big, but it isn't very small either. So I think maybe they were being a bit conservative. We'll see. Anyway, that's the transformer. Now, this stuff on the bottom here has nothing to do with the power supply. The power supply is all on this card here. Let's pull that card out. So this card is kind of a one card everything. There's the power supply was over here, and then there's all the log amplifiers and everything over here, chopper stabilized over here. So the power supply is kind of up in this area here. There's a couple diodes there. I think one of these, I think both of these transistors are actually part of the power supply. Now, they're big and they're on heat sinks, so I think we can squeeze a little bit more out of this. So what we need to do, let's move this out of the way. Okay, let's see if we can find this resistor here. It says it's oh gosh, this is a bad print, R49, I think. All right, I went and looked at the manual. It was hiding. I was looking this way, and this thing was in the way. So it's way down under here. And we've got 6.7 ohms. Good deal. And it's not very much current, so it doesn't have to be a power resistor. So it's snuck down in there. So I think I'll just put a jumper here on the back, and we'll short that resistor out, and or maybe we'll just double the current. That's probably the smarter thing to do. It's 6.8. If we put another 6.8 across it, then this thing will output twice the current. If that doesn't do it, then I don't want to go any farther than that. So I think that'll be smart. We'll put another 6.8 ohms across this one, and then put it on an electronic load and see if this thing can what it's capable of. Probably blow something up, but that's okay. If I'm going to blow something up, I'm going to replace it with another power supply anyway. All right, I was putting that 6.8 resistor across the other 6.8 ohm resistor, and then it dawned on me, dummy, that the power supply is already powering up a bunch of stuff, and I'm not going to use that other bunch of stuff, so get rid of that and you'll not have any current draw off your power supply. Duh. I don't know how many people were yelling at the camera. Do that. Anyway, so I just took my clippers and I got rid of all these op amps. And I'm sure these are old op amps, and I'm sure they're eating lots of current. So removed all the op amps, removed all the transistors. This is like the measurement side. And I said, oh, these are nice capacitors. I'll save those. So I took those off. Not going to save the tantalums, although these are really nice ones. Might pull out these resistors later on. I don't know. Anyway, I got rid of most of the current draw, I think. There might be some voltage dividers that are eating up a little bit, but maybe I just go through and cut them all off sometime. Anyway, it should be a whole lot better. In fact, it might work all just by itself, just doing that. But anyway, I'll go ahead and test it. I'll put this back in it, and we'll do a load test and see what kind of current this thing can supply. But this should be a lot better. One of the things that might be eating up a whole bunch of current was this big chopper block here. And while I was taking it off, it's just all encapsulated in a rubber compound. So yeah, nothing to see there. It's just solid rubber. So there must be secrets in there they didn't want anybody to see or something. I don't know. Anyway, maybe I'll tear into that sometime. So that came off. Yeah, nice big capacitor there. Sprague, of course. Everything's Sprague. Okay, let's give it a test. All right, got the best of me. There's this chopper thing here all filled with this rubber stuff. And that's what was inside. It is an HP assembly. Nice gold PC board. And it looks like there's an FET on the front end. And there's a Teflon standoff. And then the Teflon standoff is has all of this goo on it. So I'm assuming that the goo was to keep off humidity, to keep this thing stable, keep out any moisture at all for really high sensitivity chopper section. I have no idea what this is. It's got a cool little atom on it. Maybe it's radioactive. what does it say? EAC. Anyway, there's the part number. Everybody knows what that is. It looks like it might be a capacitor or something, like something super accurate of some type. I don't know what that would be. Yeah, I have no idea what that would be. Anyway, some nice capacitors, some resistors and stuff. Quite a few capacitors actually. So anyway, that's what's inside.